All right, so what we're going to do is take a look at graphing linear equations in two variables. Most of the time, those two variables are going to be x and y, but they can be anything, okay? So what we want to recognize is what happens when we graph a line. Well, we get a straight line, right? That's not surprising. And there's really two characteristics that define a line. That is its slope, the level of steepness that that line has, and then the location of that line. Because we can have two lines that have the same steepness but are in different parts of the graph, and we can have two lines that are in the same part of the graph but have different steepness. So if we can classify the steepness, which we're going to call slope of a line, and also the location where that thing is, that totally defines where a line is. So to see that behavior in action, you can see we have a line here on our graph. So let's play around with those two characteristics so you can start to get an idea of how they affect the graph. So here I'm going to move what we call the slope or the steepness of the graph right here. So we can see it's changing. Like in some ways the line is pinned in the same location, but the steepness of this line is changing, right? This has a very steep slope. This is not as much of a steep slope. And then here we would say that this has a slope of 0. Okay. Now, an increasing function like this, think of it if it's a bank account and your money is increasing over time, you would get an increasing function, right? If we were trying to represent a function where an amount was decreasing, for instance, if you're losing money in your account, then it's going to look like this. So that's a decreasing function. This would correspond to a negative slope. Increasing functions correspond to a positive slope, okay? And like I mentioned, we can keep the slope the same, but then change that location. So see how the steepness of this line is staying the same, but I'm changing where it's located on the graph, okay? So we want to be able to get our hands on that information and be able to figure out, well, what is the steepness? Can we assign a number to the steepness or slope of this graph? And then can we also assign a number to where it's located? And here we get what is called a slope formula. You need to know this slope formula. It's going to come up a lot. It's not too hard to remember because the truth is you're going to use it every time that you have to calculate a slope. So it's pretty reasonable that you would just have it memorized because you're going to use it so often, okay? But it's not a bad idea. Each time you do a problem where you have to use the slope formula, just write it down. And if you write it down each time you do the problem, what you're going to realize is you have it memorized and you have it learned, and then eventually you won't have to keep writing it down each time you use it. So it's a good idea while you're learning it, though, to do that. So let's say we have 2 points, and when we say x1 and y1, that's just a way of labeling them, because if we have 2 points, we have 2 x values, right? We also have 2 y values. So how do we tell the difference between the 2 x values? Well, you label one of them with a subscript of a 1 and one of them with a subscript of a 2. That way we can always tell the difference. So in this first point, we give the x and y values a subscript of 1 so that we can remember, oh, those are the values from point number 1. And then over here, we give them a subscript of 2 so we can remember, oh, that's from the second point. Okay, our slope formula in general then, remember, is rise over run. That is the vertical change over the horizontal change. Well, vertical are y values, horizontal are x values. That means our slope formula is y2 minus y1 over x2 minus x1. Okay, so let's do an example. If we have points 2 and 2, 3 and point 57, well, then if this is x1 and y1, and over here we have x2 and y2, then all you do is substitute those values into the formula just like we have up here. So this would be my y2. See how this y value in the second point is what we call y2. So that goes here where y2 is in our formula. The x2, the 5, that goes where the x2 is in our formula. And then the same thing here, right? But you have to make sure you're putting things in the right place or your slope's going to come out incorrect. All right. Then what you do is you simplify the top and bottom. 7 minus 3 equals 4, and 5 minus 2 equals 3. So we get a slope of 4/3. So the ratio of the vertical change to the horizontal change to get from this point to this point is 4/3. Okay, so let's go back to our graph and see what that looks like. If we start at this point and we go up 4, right? Remember, rise over run, and the slope we got was 4/3. So if you start here and you go up 4, 1, 2, 3, 4, and then you go over 3, 1, 2, 3, notice that it puts you right back on the other point. So the slope is giving us, it's the ratio of the change in y to the change in x for a line that would go through these 2 points right here. And we can see there's the line that would go through those 2 points. So we would say that this line has a slope of 4/3. So what we want to do then to graph a line is we want to find some points, and then we can draw a line through those points. Now, technically, a line is just defined by 2 points. So if you find 2 points, you can draw a line through it. But it's dangerous to just graph a line by plotting 2 points, because if you've made a mistake somewhere, anywhere in the problem, your line can be completely off, like not just off by a little, off by a major amount. So what we want to do is plot at least 3 points. Okay, so let's try to graph the equation 2x plus 3y equals 6, and we'll do it by filling in this table. Now, sometimes you'll be filling in the table and it'll be completely blank. In that case, you can pick the values that you put in there, but you can only pick one. Once you pick one, either the x or the y, then you have to solve for the other one. Now, some of the easiest values to pick are 0 because it simplifies things. So let's fill out this first row first. Each row is going to correspond to a point on the line. So here we have, this point is going to have a 0 in it. That means it's going to be an intercept. In fact, since this has an x value of 0, this will give us the y-intercept, which is a special point. So let's see how we would go through and figure that out. So remember, we're going to try to figure out the point when x is equal to 0 and see what the corresponding y value is. All right, so we will start with our equation, 2x plus 3y equals 6. And remember, we are concerned about the values when x is equal to 0. So what we're going to do is take this equation and rewrite it, except everywhere there's an x, we're going to put a 0. So then you're going to do that. You're going to go through and get your 0 in there. So we're going to get 2 times 0 plus 3y is equal to 6. Okay, see how I've changed that x into a 0 because that's the information that we have. Now what we need to do is solve for y. So 2 times 0 would be 0, meaning that our next line would be 3y equals 6 because the 2 times 0 is 0. It just goes away. Then when we divide by 3, we're going to get y equals 2. So what that means is that when x is equal to 0, y must be equal to 2, and that gives us that there is a solution to the equation 0, 2 is a solution to the equation 2x plus 3y equals 6. So now we can fill out that first row. So we go back to our table, and we know that when x is equal to 0, the corresponding y value is equal to 2. That's what we just figured out. So now we go back to our table and we put a 2 in there. Now let's figure out another point. Now this would be the x-intercept because our y value is equal to 0. So now what we're going to do is go in and try to figure out what this blank space is. So now we just have to go back to what we were doing a minute ago. Okay, so recall that now we're trying to solve this equation and we want to figure out what the x value is when y is equal to 0 because that's the part of our table that we're trying to fill in. That's the point that we want to find. So what we're going to go ahead and do is we're going to substitute 0 in for the y value in our equation. So we get 2x plus 3 times 0 equals 6. We've just turned that y into a 0. And then since 3 times 0 is 0, it basically just goes away. And then we're going to end up, when we simplify this, with just 2x is equal to 6. And then when we go through and divide both sides by 2, we're going to get that x is equal to 3. So what is our conclusion? Our conclusion here is that when y is equal to 0, x is equal to 3, which means that the point 3, 0 is a solution. So remember, when we're writing things as points, the x value comes first, the y value comes second, right? Even though in this case we knew the y value ahead of time, it's still the second component in the point. The x value is the first component in the point. So now we can go back to our table and fill that value in. So we go back and say, okay, well, when y was 0, we figured out that x was 3, right? And so we'll fill that part of the table in. Okay, great. Now we have our 2 points. So technically we could draw this line, but again, it's very risky. If you just do it with 2 points and you've made any kind of minor error, your graph can be wrong by like a lot. Like not where it's close, it's like completely wrong. So what we want to do is find a third point. You always want to graph at least 3 points to determine a line. Now you can do this for yourself, but what you'll find is if we try to do the same thing we just did, but when x is equal to 4, we're going to get a fraction over here. Now that's okay. The problem is if you're trying to graph things by hand, fractions can be a little bit difficult because as you'll see in a moment, when we plot things and they fall right on the grid lines like these will, it's real easy to be accurate with where those go. But once you start trying to figure out where the fractions fall on a table and you're doing it on the graph and you're doing it by hand, it can lead to a less accurate graph. So what you want to do then is play around with some x values until you find ones that come out to nice, clean integers. Now, this is not always possible. Sometimes you're going to have to deal with fractions, and it's not a huge deal, but it's kind of nice to be able to deal with integers when you can. So you would just repeat the process that we went through for this -3 right here. You'd plug that in for x, see what your corresponding y is, and if all 3 of those points line up, then you're good to go. You know that you didn't make any kind of mistakes in there and that your line is correct. Okay, so let's jump over to Desmos and see how this works out. Okay, so let's plot our points that we were looking at. This is our point 0, 2. And here we have the point 3, 0, right? Those are the 2 points. And then if we were going through the whole process, we should have a third point in there and it should line up with the other 2. If it does, then we're pretty confident we did it correctly. And then you want to take something straight, right? In human beings, we love straight lines. So there, pretty much any room you're in is probably full of things that have straight lines that you could use to draw a straight line. The edge of a book, an extra pencil, all sorts of things can give you enough that you can make a nice straight line. Most people are pretty bad at freehanding a straight line, and it ends up looking really bad and being kind of low quality line unless you happen to be an artist and you're really good with this kind of stuff. So it's worth the couple extra seconds to find something, the edge of a calculator or something, where you can make sure that your line is going to end up straight. Then you draw a line through it and you get a line right there. And you've now graphed the line 2x plus 3y equals 6. Now, there are a couple special lines that are confusing to people, but once you get the hang of it, they're actually not bad. That would be horizontal lines and vertical lines. So let's take a vertical line first. Say x equals 2. So the rule for this line is that the x value always has to equal 2. The y value can equal anything, but the x value is equal to 2. So notice what we have here. If you look at all these points, they all have an x value of 2, but then there's all sorts of different y values. So if you just think about it, because people mix them up, and they can't remember, is x equals 2 a horizontal line or vertical line? Well, just think about if you were to start graphing points where all the x values were 2, they would line up vertically. Right, so we get a vertical line, and if you want a horizontal line, then that would be y equals 1. And you do the same exact thing if you want to do it with a table. It's just that in this problem right here, all your y values would be 1, so that second column would all have 1s in it, and the first column you can fill in with whatever you want. Whereas over here, to do this one, the first column would all be 2s, and the second column could be filled in with whatever you want. So we really do it the same way. The horizontal and vertical lines aren't very hard. I think people overthink it. They kind of think that it's harder than it is, and they put too much thought in it rather than just sitting down and graphing it for what they see there.